Hello again. So far we've looked at vectors through their geometric representations and added them and subtracted them. Today we're going to look at them algebraically. All right, so let's consider a car traveling at 80 kilometers an hour in a northeast direction. So here I have north drawn here, and northeast, this would be east. So northeast would be halfway between those two. And we know this is a 90-degree angle. So northeast is 45 degrees from north. That's this angle here. I've drawn a vector with a magnitude of 80 to represent the 80 kilometers an hour. And you'll notice that this distance here, that gives me my x component. And this distance here gives me the y component. You'll notice that we named both of these A, and that's because I have a 45-degree angle here, a 90-degree angle here, and that leaves me a 45-degree angle here as well, which is a special right triangle. And we know the sides are equal. We can find the x and y coordinates if we use Pythagorean's theorem. So Pythagorean's theorem says that a squared plus b squared equals c squared. Well, both of our sides are a, so a squared plus a squared equals, and we know the hypotenuse is 80, so 80 squared, which I have two of those a squareds. And 80 squared is a very big number, but it happens to be, let's see, 8 times 8 would be 64, so 2a squared would be 6,400. And then I'd go ahead and divide by, not 3, 2. So a squared equals 3,200. And that means that a equals plus or minus the square root of 3,200. And when I look here, both of these distances are those coordinates are going to be positive. This x distance will be positive and the y distance will be positive because I'm in the first quadrant. So I'm only going to take the positive value of that, and my side lengths are roughly 56.6. So we've already looked at a number of ways to represent vectors, but there's something called a column vector. And in the column vector, if we wanted to represent this vector here, representing this situation, I would put the x component on top and the y component underneath it in a column. This kind of a vector actually has its advantages. It tells us more about the vector we have here than just calling it, I don't know, v, vector v or whatever, or vector p to r. This gives us more information. It tells us how far and the direction we're moving in the x direction or horizontally, and how far and what direction we're moving in the vertical direction. So my first example, I'm going to draw vector A, and that equals 2, 3. It's the column vector 2, 3. And you'll see here that 2 is the horizontal movement. We actually call that the horizontal step. And it is what we know as the x-axis or the x direction, not axis. It doesn't have to be centered, it can be anywhere, but it's horizontal. And then 3 is the vertical step. which we refer to as the y. So we can start anywhere here, but wherever we start, we need to move 2 right, because I have positive 2 horizontally, and then the end point of my vector is going to be 3 steps up. And that's the direction, so I need to put the arrowhead in the direction that I draw the vector. And that's how you draw a column vector. How about you try the vector -1, -3. Pause the video, try it out, restart when you're ready, and we'll check your answer. So it's a little noisy in here right now. It's because I'm here after school making a video for you, and the janitors are cleaning up. So that's what you hear, is the janitor cleaning the floor. Say hello, kids. All right, so let's check your answer. If you start anywhere, oh, can't start until you have a pencil. Okay, so I know I'm going to have to go in the negative direction both times, so that means I need to start over here somewhere. I'm going 1 in the negative direction horizontally, and then down 3, so that's where I need to end. So I start here, end here. So that's it. That's all there is to it. What that does for us, putting vectors in component form, allows us to add vectors algebraically. If you look here at vector A, I'm going to draw him in red. I have vector A here. Starting here, that means that this distance here, let's change that color. Let's change that to black. Okay, so this distance here, from here to here, is my x component, and we'll call that A1, all right, for the x component. And then this distance here would be the y component, and we'll call that A2, right there. Okay, so for vector B, let's change his color so we can take a better look at him. Oh, there's that janitor again. Tip to tail, I'm starting at the tip of the last vector with the tail of the new vector, and I'm adding. Here's my x component. Oh, changed pen again. Here's the x component. So we'll call that B1 for vector B and the first entry. And there's my y component, so B2. All right, so if I looked at the resultant vector, that's all the way back here. Oops, that's not what I wanted to do. How do I undo that? Yep, that's how I undo that. Okay, so if I look back here, there is the resultant vector. And if I look at the distance, my x distance for the resultant vector, you'll notice I have this distance, and I also have the distance B1, so that's A1 plus B1. And then if I look at the resultant vector from top to bottom, or horizontally, that's B1, the distance B1 here, and B2 together, so A2 plus B2. Sorry, that was A2, not B1. Not B1, A2. A2 is this distance, B2 is this distance. So if I wanted to add these together, for the x component, I have a1 plus b1, and for the y component, I have a2 plus b2. And that gives me those two vectors added together. So let's try an example. I have a equals 1, negative 3, and b equals 4, 7. I want to find a plus b, and then I'm going to check my solution graph with the graph. So a1 is 1, plus b1 is 4, and then I have negative 3 as a2 and 7 as b2. And the result of that is 5, 4. So let's check that on the graph. If a is, that's a plus b. If I start with a, it's 1, negative 3. I'm going to have to go 3 in the negative direction, so I'm going to start up here somewhere. So over 1, down 3. Okay, and then b is 4, 7, so over 4, and then up 7. 1, 2, 3, 4, 5, 6, 7. So that's where b ends, or the direction b is going. Now if I want to find the resultant, that's this vector here. And so I need to check the horizontal component, and that's 1, 2, 3, 4, 5. That's what I have here. And then I have 1, 2, 3, 4, which is what I have here. So that checks out. So that's it for adding vectors. When you're ready, watch the second video on subtracting vectors.